at this paper 1 question, I want you to just look at it for 10 seconds. And then I'm going to show you another paper 1 question. So look at the whole thing. Have a quick look at what it's made up of. Okay. So 3, 2, 1. And then let's look at another year's paper 1 question. And so just take 10 seconds to read it and look at it. And I want to ask you, do you see similarities in the way that it's presented? So what do you notice is occurred in both years? Or what's in common, or were there any similarities between the 2 years? What did you notice in both of them? You don't have to say all of it. Just give me one thing that you noticed was in common to both years. So question structure, absolutely. You can see that you have a very similar question structure. Yeah. Any specifics? Thanks, Romeo. So you definitely almost always see a simultaneous equation. You see a question where you have to use the formula. You see a surd equation. You see an inequality. Sometimes you'll see something along the lines of nature of the roots. And then there's normally some general equation solving to start the paper. So there's very much a structure that question 1 will always have. And we can even look at another old question paper. This is a 3rd year's question 1. And again, you see a very similar structure. There's a little bit more here about surds and nature of the roots. But essentially, question 1 will always look the same pretty much until even in a trick, your question 1 will look the same. So today, what we're going to try and do is just work at any like uncertainties that you have in your basically. So let's start. I want you to do question 1.1.1 and 1.1.2 to start with. And over to you guys. Let's just make sure you do those. And then when you're done, you can just put your answer in the chat. However, if you have a question and you feel a bit unsure of something, just pop it in the chat, or even have a audio question. You can just ask me about something. Okay, nice, Romeo. Nice, Figelo. So when they say correct to 2 decimal places, that is code for telling you that you need to use the quadratic formula. So whenever you see that, it's basically giving you instructions to say you should use the quadratic formula. That is on the formula sheet, but yeah, so well, I can write it down if it's helpful for you guys. And then I just want to make sure that you are applying it correctly. That's the formula. Oh. So Romeo, you possibly could solve it without the quadratic formula, yeah. Well, actually, no. 1.1.2, it literally says correct 2 decimal places, but you would have to complete the square, but I wouldn't recommend choosing to complete the square unless they ask you to do that. So my recommendation would be whenever you see correct 2 decimal places, straight to the formula. It's 3 marks. And so, yeah. So your what we call the delta value is the value inside the square root bracket or the root bracket. It should be 124. And now you get your 2 roots because of the plus minus in front of it. And I'm interested to know what you guys get for your roots. So I see Shoshana, Neo, Darren. A couple of people have put their answers in there. Keep going ahead. And then I'm going to give a little bit more time before I reveal the answers. If you have a moment, though, the next question we're going to do is 1.1.3. So if you'd like, you can start on that while we just finish off this one. Okay, so your answer should be 0.91 or minus 1.31. Okay. Any questions or comments? Thumbs up if you felt okay with that. And then we can move on. Are there any questions or comments? All right. Cool. Now, what I want to know is what type of question is 1.1.3? What type of question is 1.1.3? And how do you know it's that type of question? What gives it away? What am I looking for that tells me? Yeah, it's an inequality. And the reason I know it's an inequality is of sort of, I call it the crocodile mouth sign or the greater than or equal to bit here. Exactly. So that is code for it. An inequality gets treated a lot like a equation, except for some subtle differences. So I want to give you, I'll give you some time to do this, and then I'll make some suggestions first. I think it's better you try it first, and then I come along. So I'll give you 60 seconds, see how far you can get before I start making any comments. Okay. So when we deal with the inequality, it's a lot like an equation. So my first step was just to bring the -3 across. And the next step that I would do if I was solving an equation is I would find the answer either using the formula or I'd factorize it straight away. I'm going to choose to factorize this. And if I factorize it, I am seeing that as the value. So 2x plus 1, x minus 2 is greater than or equal to 0. There's different ways of doing inequalities. Some people like to visualize this. So if you think of this expression, this is actually a quadratic expression. And so it's actually going to look, it's going to have like a happy thing like this. And to solve the inequality, we need these critical values or these 0 values. And so, and these 0 values are going to be placed on a number line to show my answer. What are my critical values? They're just the values that make this expression 0. And so my two critical values are going to be -1/2 and 2. Now, I want to know where this expression is greater than or equal to 0. If you look at my little drawing, it's basically going to be here and here. This drawing is one way of knowing it, or I could choose a number greater than 2, like 10, and sub it into the expression. And you see this expression is positive here, negative here, positive here. And so sometimes they call this a sign table because it shows the sign of the expression as the x value changes. So how do I actually read off my answer? My answer is where it's positive or 0. And so what I do is it's 0 over here. So I color in this dot and it's included. And then over here, I'm going to color in this dot and it's going to be like that. And so the answer is going to be x is less than or equal to -1/2, or x is greater than or equal to 2. The reason it's got greater than or equal to is because when I started, the question had a greater than or equal to. And so I have to include my endpoints. Now, inequalities take a while to get used to the method. Are there any questions or comments about that? We'll do another one in the lesson, but I'd like to know from you now, is there anything you want me to clarify? Yeah, Lesego. Let's unmute you there. Yes, go ahead.
Sir?
Yeah.
Does the negative in the 3x cause it to be, cause the x to be less than equal to the -1/2, or
Okay,
less than equal to the 2? I don't know if I worded that correctly.
No. Okay, now the negativeness or the positiveness is of this whole expression. So this expression is positive or negative depending on what x value you put into it. So what happens is, if you want to visualize what happens, if you look at this little sketch at the top, because of the power of 2 here, this is a parabola, right? It's like a happy parabola. And so this shows you what happens. When the x value is here, the value is going to be negative. When the x value is here, the expression is going to be positive. When the x value is here, the expression is going to be positive. Now, what we really need in our lives, though, are these two values, what we call the critical values. And that's where this bit helps. So the critical values are 2 and -1/2. Now, when it's greater than 2, this is positive, like I showed here. And so that's why we include 2 and numbers greater than 2 in our answer. And numbers that are less than or equal to -1/2 also get included. Another way of doing it, Lesego, is to say, choose a number bigger than 2, like 10. If you put 10 into this expression, you'll see 10 squared is 100, times 2 is 200. And that's so big already that these other terms aren't going to make a difference. And so this expression here is positive. Whenever you go over a 0 value, unless it's a double 0 value, it changes its sign. And because I'm looking for when it's greater than 0, then I just look for the positives here. Yeah. So are there other questions? We probably need to do another one. So let's see how it goes in the second example in the lesson that we're going to do. Okay. What I want now is I want everyone to try and do the simultaneous equation question. While you get busy with that, I will also take more questions on the inequality though. Some of you may want some more clarification, so please do raise your hand and we can chat further. Otherwise, you can get on with the simultaneous equation just to check. We're going to go back, David, and do 1.1.4. I just wanted to first check that you're okay with simultaneous equations, because if you are, I might leave them out later in the lesson, because so while you're doing this, the top tip I always tell my students is to always put the easy equation into the hard one. So I would label this first one as the easy one and the second one as the harder one. And so we always try and substitute like that. And we always try and take the easy one and we choose the variable that will make our life easiest when we sub in. So you could make y or x the subject. Which of those two will make your life easier is my hint. You can get there both ways, but I'm just, yeah. Okay, so I see a couple of answers coming through in the chat. There actually is a choice in this question. You can use the formula to find your x values, or you can also divide through by -2 to make this trinomial easier. So I see that there's sort of a common factor floating around. So what I'm going to do is divide by -2, but the formula will also give us the same answer. So I definitely am getting that x is 4 or x is -1. Now, that isn't the question complete. I still need to find the y values. Does anybody know how we get the y values, or what's the best way to get the y values? So I would, yeah, was there a person? I would think that, yeah, David, let's go to you.
Sir, what you're gonna do is these two values, 4 and -1, you're gonna substitute it to the equation where you
Yep.
highlighted in green.
Yep. So you take this bit over here, and you are just going to sub it back into the equation that you started with. And so you should get, when x is 4, you're going to get 2 minus 4 is -2. And when x is -1, you get 2 minus -1, which is going to actually give you 3. Now, it's a bit sneaky the way I got the 3, but it is the truth. So, okay. Any questions or comments about that? Is everybody happy? I almost, yeah. Simultaneous equations are pretty common. Okay, so before we have our break, we're going to have a crack at that one question that we left out, unless there are any comments that need to be taken into account. Okay, so I left out 1.1.4, and I want to give it a bit of attention now. Why is 1.1.4 a bit different? I'd love to hear some opinions. What makes it a bit more spicy than normal? And what techniques might we have to use to undo the spiciness? I think of milk. Sometimes when I eat spicy food, then I'm like, oh, that's too spicy for me. I'm a lemon and herb kind of guy. And then I have to get milk, right? So then, yeah, same sort of thing here. David.
Okay, so I'm not sure. What I think is the square root of 2x plus 5, you're gonna multiply it by -2 and by the other square root of 2x plus 5.
Okay, so what I'm going to grab from that, David, is that this bit down here is a fraction, and that makes life a little bit difficult. And so you need to multiply by that to get rid of it. Neo's made a very nice suggestion. He has mentioned the K method. Has anybody seen the K method before? And the reason the K method could be useful here is it takes messy things and kind of just puts them on the side for a while. So that's the one way we could do it. The other way we could do it is by multiplying through both sides by this denominator. Okay, so that could also work. Those are both choices. Okay, let's have a vote here. If you want me to do it with the K method, put a 1 in the chat. And if you want me to just multiply both sides by the denominator, put a 2. So basically, no K method, just do it normally, etc. Okay. 1 and 2. Okay, let me show you how the K method works. It is useful. When you see an equation that looks a bit of a mouthful, but there's a similarity between two parts, to make it simpler, we say let the part that looks a bit funky be K. Now, it didn't have to be K, it could have been something else, but I think K was available, so we took K. So if we use that substitution, can you see that that equation where K has been subbed in is a lot easier to deal with than the equation up here? And it's the same thing. It's exactly the same equation. Now, what we're going to try and do is we're going to solve this equation in K. And in order to solve this equation in K, I'm still going to have to deal with this bit here. So what am I going to do to deal with that k hanging out at the bottom? It's still, making trouble. So I need a mathematical technique that treats this equation as an equation, but, So you're going to multiply everything by k. Exactly, Chloe, exactly. And you should then get k squared minus 3 equals minus 2k. And then you bring that minus 2k across, and you get this. Now, I want everyone to find me the value of k that solves this equation. Find me the value of k that solves this equation. I feel like I'm running out of space here. Don't mind me while I clean the board. Okay, so k is minus 3 and k is 1. Is the question actually done yet? Yeah. Leseko.
So, well, the question isn't done, but I want to know a bit more about that method you used to figure out which, with the 3 and the 2 there. I've never seen that before. I want to.
Okay, so you don't have to use it like that. This is a method for factorizing a trinomial. Do you use, can you factorize this trinomial? It doesn't matter what method you use, as long as you're getting the same as me.
Yeah, it just takes a lot of thinking.
Yeah.
I kind of go through a trial and error process. So
yeah, there is trial and error to this as well. It's just, it was a very simple one. Can I suggest, I'm not going to go through it right now, but I'm going to make a note where I go through trinomial factorization in future, because I think right now today, I'd rather spend the time on other things, but I take your point. The other thing you could have done is, if you didn't want to factorize it, is you could use the formula, but that would also take quite a bit of time as well. So it's a bit of a 6 of one, half a dozen of the other. Okay, so I will get back to that, Leseko, at a future time.
okay.
Cool. So now what happens is, and this is becoming a bit of a monster, isn't it? I suppose it's 6 marks. We put it back in and we get 2x plus 5 equals minus 3, or we get square root 2x plus 5 equals 1. Now, the question is, what are we going to do next in this journey? What is making life difficult?
Any hints, guys?
What undoes a square root? That is a question.
Chloe and Loreto are onto something.
Square both sides. Fantastic. Yes. So I square both sides and I get minus 3 squared is going to be 9. And over here, I'm going to get 1. So what are my final answers going to be? What do we get for our final answers? And there's one extra step with surd equations that we have to do also after we've even got our answers. I know, surd equations. Oh my goodness. See a couple of answers coming through. So if I take away 5 from both sides, I get 4, and then x is 2. And then on this side, 2x is minus 4, and then divided by 2. Okay, now we are not actually done. The two possible answers are 2 and minus 2. But in order to know that these are answers with a surd equation, we have to do one more thing. What is the final thing that we need to do in a surd equation? To make sure that you have to check your answers. Yeah, you have to make sure that they actually are true, because it's possible to introduce some false roots. So if I look at these answers here, actually let's go back to the original equation. Which was the original equation? So if I take, these are the two possibilities. There's x is 2 and there's x is minus 2. Now, if I go back to the original, 2 times 2 is 4, 4 plus 5 is, so that's 9 minus, let me actually bring up the answer here so we can check it. X is minus 2. Why would we reject it? So look. Oh, yes. Okay. Okay. I'll come back to this in a future video just to emphasize this. But what we're doing is we're rejecting the 2 because the square root here, if you think about, if I put a 2 in here, 2 times 2 is 4. 4 plus 5 is 9. Are you with me? Now, in terms of this equation, it's going to be defined as the positive root, which means that this is going to be rejected. This one over here works fine. 2 times minus 2 is 4. So minus 4 plus 5 is 1, and the square root of 1 is 1. And so that's why we're only going to keep this answer over here. I do want to do a quick little check, though, just to show you maybe there's a bit more kind of working out I can show you. These, because it's no, that's the other one. Sorry, guys, just give me a second. Yeah, okay, that's the bit I wanted to show you. So let me get some space, and then I will. Okay, so the part that I want to emphasize here is that we're rejecting the solution where we get the square root here, because by definition here, it's going to be the positive square root. And so we needed to end up with a negative 3. And so that's why we're rejecting that side of the equation. Okay. David, yeah.
Oh, yes. So I wanted to ask you a question. Can you scroll back down?
Down here?
Actually
Ooh.
up. Yeah, actually up.
Yeah.
Okay, I got lost from when 2x plus 5 equals to 9 and 2x plus 5 equals to 1. From there, yeah, I got lost.
Okay. So all I did was 2x plus 5. I squared both sides. If I square minus 3, I get positive 9. If I square the square root of 2x plus 5, I get whatever's inside. If I then take away 5 from both sides, I get 4. And then if I divide both sides by 2, I get 2. So are you with me there, David?
Yes, sir.
Okay, now, what I was saying was if we check, and we can check by even putting it back into the original K formula here, that 2 times 2 is 4. 4 plus 5 is 9. If we square root 9, by definition here, it's the positive root only. And so that's why we can't get the negative 3. So we reject the answer here. Whereas on this side, 2 times minus 2 is minus 4. Minus 4 plus 5 is 1. The square root of 1 is positive 1. So that's why this side is happier.
Okay. Thank you, sir.
Pleasure. All right. I ran a bit long because I went into that surd equation. Let's all stand up for a second and give a nice stretch. So turn on your cameras, and after that, we definitely all need a stretch.
Please join us in the stretch, guys.
Oh, stretch it out.
Turn on your cameras. Let's see your lovely faces.
Oh, that is good.
Shout out to David. Shout out to Lucijo. Shout out to Shisana. Don't miss out, guys. We've been working for 40 minutes. Come on.
That was, we saw the mountain and we didn't go back home. We went over the mountain.
Yes. Yes. Shout out to Katleho, Sise to Darren. It's so nice to see everybody.
There's the team. There's the team. Come on, guys and girls.
Your body will thank you.
All right. Oh, doesn't that feel good? Oh, my neck. Goodness gracious, my neck is very much happier with me. Okay, brain break. Here is your brain break question for today. What is the answer to that? So divide 20 by a half. This is going to give it away, and then add 30. Now, the sneakiness of this is when you divide a number by a half, something magical happens. It doesn't get smaller, it gets bigger. Yes, so 20 divided by a half is, in fact, you can see it by, sometimes I tell students to do this trick. So write 20 as 20 over 1, and then you do the top and times thing where you invert the fraction, and then you can see that it's 40. So if that bit is 40, 40 plus 30 must be 70. And that is the brain break for today. Okay, so watch out for those dividing by a fraction. That has caught many a student in the past. Yeah. Awesome. So let us now return to a second past exam paper question. And now I'm going to choose those questions that offer us the most excitement. So I'm not going to ask you to do, and this is a good technique. I think all of you should be able to get the answers for this and this now. Okay, so we're going to leave that one out because it's not efficient use of our time. We're going to start with question 1.1.4. And I want you to solve that inequality for me. And then we'll go on to another one that I choose that is most helpful for us. But let's start with 1.1.4. See what techniques you can remember from earlier in the lesson. So far it reminds me a lot of a quadratic equation where you put it in standard form. This next step that you need to do is to factorize it. And so let's say, this is what you were asking about earlier on. So I'll just talk you through what I'm doing. What I look at is the number in front of the x squared, which is, in this case, it's a 1. And so I just write down two numbers that multiply together to give me 1. Over here, I write down the number that is in front of the x term, or the b value. And now I have to make some choices from the numbers that make up 18. And so the numbers that come to mind for me are 3 and 6, because 3 times 6 gives me 18. And so I'm going to write in 3 and 6. I could have used 9 and 2, but it didn't feel like 9 and 2 would get me close to -3. And so basically what I have to do is I have to multiply along this cross and then add whatever the other multiplication is to get -3. So I'm going to go 1 times, so because I want to end up with a negative, I'm going to make this a negative because it's the bigger one, and I'm going to make this a positive. So 1 times -6 is -6, 1 times +3 is +3, and together that does give me that value. Now that was a very, very quick sort of explanation. You probably need to look at that a couple of times or go through that method, but you should get x plus 3, x minus 6 greater than 0 is the inequality. And now what's going to happen is I'm going to actually put my critical values on a number line. And the other thing to think about is when I do this, what is the shape of this expression? And it's a happy parabola. So it's going to look like this. And I'm after these two values. And those two values are going to be -3 and 6. Now, what is the value of the expression in each area? Well, here it's going to be positive. I could find that by choosing a number bigger than 6, like 10, and subbing it in. Or I could look up here and see that it is above the x-axis. It changes every time it goes over the 0 values. And I'm looking for when is it greater than 0, strictly greater than. Now, because it's strictly greater than, this is an empty circle. It's not including 6. And it goes here. And here is going to be an empty circle as well, because this question is all about, it's not including the 0 value. So those are my two answers there. I get x is less than -3 or x is greater than 6. Now, I think I caught a couple of you there. So let's just take some questions or comments from the floor or from the room, we might say. There's various steps. Step 1 was get it into shape. And then, yeah, well, I'll wait for questions. Are there questions or comments about this journey? Okay, so step 1 was basically move everything to one side, standard form. Step 2 was factorizing, which was like here. Oh, where's this going? So it's here. So this was standard form part. That's factorizing. And this is what we call the number line or the sign table. And then it helps us get to these answers here. But knowing when to color in circles and when not to, and the answers to an inequality are always going to be a region. So it's like, it's all the numbers that are less than -3. So it's like -4, -5, -3.5, and then all of these numbers. And because this isn't colored in, it doesn't include 6. And the reason it wouldn't include 6 is, think about it. What's 6 minus 6? It's going to be 0. What's 0 times anything? It's 0. Is 0 greater than 0? No. So that's why it's an empty dot here. Okay. Any questions or comments? All right. Then let me try. Okay, I'm going to come back to surd equations at the beginning of the next lesson. So that is a surd equation. But I just want to quickly have a little look at 1.3 to finish the lesson today. So it says, if f of x equals 0 has the roots this. for which values of k will the roots be equal? Now, this sounds a little bit like it's speaking another language. Can anybody identify what section is this coming from? What theory, like it's got to do with roots, and f of x equals 0 is some function, and it has, what does this remind you of? What does this block? Where have you seen like a structure like this before? And then we'll talk about the roots being equal. Okay, so nature of the roots is a good tip, Shoshana. Yes, nature of the roots. And the reason nature of the roots is involved is, isn't this the quadratic formula, right? So this is like, it's almost like they're saying there was some equation equals 0. Here are the roots. For which values of k will the roots be equal? So we're asking ourselves basically about, the roots are like the solutions to an equation. But now there's a part of the quadratic formula called delta. And delta is the b squared minus 4ac part. And delta is always hanging out inside the square root bracket. So in this question, delta is this. Now, when delta is equal to 0, you have equal roots. And the reason you have equal roots is that in the quadratic formula, there's a plus minus in front of the square root. If delta is 0, it has no effect on the answer. So say, for example, here, if my delta value was 0, what's plus or minus 0? Or the square root of 0 is 0. If delta is nothing, the answer is minus 5/4, right? It has no effect. So what we do, we don't have to solve the whole equation. All we do is we say, for equal roots, delta will be equal to 0. Therefore, let the delta value that you have here equal 0. Now, what I want you to do is I want you to find me the value of k that satisfies that equation. There's a couple of different ways you could do this. I'm being a bit sneaky here, but there's another way of doing it, which I think a lot of you would do it like this. That's also fine. I made a mistake here. Hold on. I have made a mistake. Sorry, guys. I'm talking rubbish. I think I'm rushing. There's a couple of different ways to do this. You probably could have got there in less time. Here we go. Now, if we did it like this, some of you may have done it like this. You may say, well, actually, I'm not sure if you did it. You probably would have done it like this. No, I don't think there's. So some of you might have divided by 12, in which case you get a quarter equals k squared. And then if you square root both sides, you get which equals plus or minus a half. Now, that was actually quite a tough question. But there's always going to be, this is what we would call a problem solving or complex procedures question. So if you found that tough, don't worry, it was designed to be a bit tough. But the main thing that you could have got 2 out of 3 marks by just getting this bit and essentially that bit, you know, like from there, I probably went the long way here. And so it might have been a bit shorter to go here, but essentially, you could have got 2 out of 3 pretty quickly and easily. Are there any questions or comments before we bring this lesson to a close? On Wednesday, what's going to happen is I'm going to carry on going through question 1 and 2. And so we'll keep practicing these types of questions. Yeah. Leseko, what is your question?
So, sir, if they ask us a question like 1.3, this is exactly how you do it.
There's a couple of, the thing with maths is there's always more than one way to do it. What I really want to get into your head today about question 1.3 is that when you see the roots will be equal, I want you to know that delta tells you stuff about the roots. Okay. So if they say to you, when are the roots non-real, then you need to know delta is less than naught when the roots are non-real. Delta is equal to naught when the roots are equal. And then delta will be real roots when delta is greater than or equal to 0. So there's some theory about delta, which over time I want you to sort of update about, but I'm not going to do it all in one day. I just want to make you aware that delta can tell you stuff about the roots of an equation. And that's what nature of the roots is all about. Okay. And Nizole, what is your question? Okay. Nizole, have you got a question there?
Not sure she's asking about the signs and
Okay.
cities.
Okay. No, so I did make an error initially, and now I've corrected the error. So you can see both answers are the same over here. All right. Now, again, if that last question threw you for a bit of a loop, don't stress. Most of the time, you know, the questions we've done throughout the lesson today, you guys have done fantastically well. I'm just starting to include some more of those more difficult questions as we are building a good foundation on which to build. And the thing that I want you to really always point out is there's always partial marks available. Even if you don't get the hard questions perfectly right, you gobble up the easy marks inside them. And that's something to bear with you. Okay. Lebo, could you please put the poll out? We're going to call it there for today.